Hello everyone. Today I'm going to present my poster. My name is Mohammad, graduate student, Civil Engineering Department. My advisor is Dr. Mohammad Abdul Rahim and the poster title is Initial Investigation of a More Sustainable Method for Constructing Electric Conductive Pavement. Here is the track of my poster presentation. Snowfall is a major concern of the northern part of the US due to its negative impacts on the three dimensions of sustainability, environment, economy, and society. Snow on highway can lead to pavement failure and cause accidents. Previous research studies reveal that about 15% of vehicle crash occurs on the road due to accumulation of ice and snow on the pavement. Currently, ongoing research explores different methods to melt the snow accumulating on the surface of the pavement efficiently. However, based on findings documented in these research projects, the proposed methods are not financially feasible. This poster presents an initial investigation of a new sustainable construction approach for melting the snow by heating the pavement using modified conductive composite applied to the surface of the pavement in an optimized pattern. Transportation system is continuously developing since its time, which help to the rapid growth of urbanization. So transportation safety is the main issue of people. That does not only depend on the passenger, driver, vehicles, characteristics of the highways, but also overall climatic condition. Moisture, ice, and snow on the pavement are critical factor of natural climatic condition, which led to brake failure and cause accidents. Moreover, it leads to substantial economic damages, fatalities, injuries, latent safety on the road, and roadway capability. The main three sectors of transportation, air, rail, highway, also affected by the snowfall. For instance, the flight will delay on the airport, train cannot leave the station timely, motor vehicle are hindered of movement on the highway. There is currently ongoing research to explore different methods to melt the snow efficiently. Although some of the findings are promising yet, most of the methods are not feasible financially. The objective of research is that currently ongoing research claim that it can be efficiently melt snow from the pavement. However, they are not financially feasible because of previous project and research have revealed that all methods are pricey and economically not viable. So it's essential to conduct research where we can find an alternatives or modify the application of methods in order to satisfy financially feasible and would effective solution for melting snow. The hypothesis that if the surface of the pavement coated by conductive coating with conductive composite material would work similarly to the rear windshield over the car, a conductive paint. According to the principle of Joule heating, while current passing through the resistor can be heated up. Therefore, using coating composite as a resistor to control the desired resistivity can generate the required amount of heat to top of the pavement surface, enabling for melting ice and snow from the pavement. In our project, we used graphite powder as a conductive filler with carbon content 99.35% and water-based polyurethane used as a polymer content, which is full cured 5 to 7 days and set to touch 6 to 8 hours. The composite mixed with GP and water-based polyurethane is supposed to be used on the Portland cement concrete pavement, hence intended for the reducing curing time, which will enable shortening the closing time for traffic on the coated surface. Therefore, instead of incorporating any solvents, this study involved using fast-drying water-based polyurethane, which eliminates the duration of required evaporation of solvent to set the composite. This research goal is to investigate the viability of using water-based polyurethane and graphite powder composite as an electric conductive coating for constructing heating pavement. The synthesized composite applied on the top surface of the Portland cement concrete pavement. The optimum amount of GP doses is determined by using percolation threshold theory to achieve the desirable resistive property of electric conductive coating. The property of heating capacity of conductive coating measured with infrared thermometer by maintaining controlling parameter. The received graphite powder gently mixed with water-based polyurethane for 3 minutes with 250 rpm at room temperature. The composite was applied to the specimen surface using brush once prepared following procedure. Using the required mixture proportion, 2 types of coated specimen on wood and P substance were prepared for measurement electric conductivity as shown in figure 1. Wood substrate was used because the electric conductivity of dry wood is low enough to ensure there were no interference with conductivity measurement. Air-dried Portland cement concrete substrate was used to simulate the real condition in the intended application of this coating materials on PCC pavement. Since the result of the measurement on the two groups specimen were comparable, the final electrical conductivity was taken as the average of the measurement results on both substrates. The copper tape was applied to the two ends of the specimen to used as electrodes in measurement of resistance. Through probe method is a reliable and accurate approach for resistance measurement we utilize in study. To determine the optimum amount of graphite doses in the polymer content along with achieving desired conductivity of composite, used a tool called name as percolation threshold, which is an excellent method to explain the electrical behavior of the composite. The polymer content in the matrix work as insulator to reach higher conductivity of the composite. Conductive filler should be introduced in the composite after percolation. Therefore, to create the continuous formation of conductive paths in the whole matrix, the volume fraction of conductive filler should be greater or equal to the percolation threshold. As seen in figure 1, the selected range of GP content result in fold capturing the percolative behavior such that the dual critical percolation threshold was found. As in figure, different zones can be distinguished in the conductive GP doses. Flood the include two abrupt increase zone and two flatter zone. First one is observed in 12.5% to 70.5%, and second one is 75% to 25%. Where it is where's this zone composite turn into insulated to semiconductor, and second one converted to semiconductor to conductor composite. Evaluate the performance of the composite coating on concrete substance in terms of strip heating. Concrete specimens were coated with composite at different GP doses rated, which were selected based on the result of a percolation threshold determination test. The GP dosage rates were selected such that the whole range of percolation transition zone and its vicinity were covered. The composite coating used instead include 15% to 30% graphite by total volume of composite. Heat generation efficiency of composite coating specimens were characterized through performing infrared thermometer and AC voltage of 20 volt to 50 volt at frequency of 60 Hz was applied to each specimen through the copper tape for duration of 30 minutes. The surface temperature each specimen was measured and recorded as explained. Figure 2 shows that heating capacity of PU GP coating on concrete substrate after 30 minutes of current application. Up to 20% graphite doses the average surface temperature at the end of electrical heating test. Increased with the GP volume fraction above 20%. GP dosage rate, and that trend was reversed, resulting in a reduction of heat generation capability. The quality of the coating with respect of surface application of heat uniformity also affects the ability of heat generation. Figure 3 shows a continuous increase of average surface temperature rise with GP dosage rate. GP dosage rates up to 20%. The temperature distribution on the coated surface between the two electrodes were almost uniform without any extreme heat concentration spots. The heat concentration can be attributed to high variation of electrical resistivity between different zones of coating layer due to poor GP dispersion. At high rate of GP contents, the composite is more susceptible to filler agglomeration. However, this is hard to capture in small specimens like those used to obtain. The coating composite containing 20% and 22.5% conductive filler provided desirable performance with regards to both the magnitude of average temperature increase and the temperature distribution uniformity. GP dosage rate up to 20%. The temperature distribution on the coated surface between two electrodes were almost uniform without any extreme heat concentration spots. Whereas 25% to 30% graphite content, the electrical energy to heat energy conversion occurred at a small fraction of coating, significantly increasing the temperature at some spots and leaving the majority of surface unheated. The composite coating 20% of graphite content exhibited more favorable properties than other coating mixtures. In future, we will focus on other properties of coating such as skid resistance and durability of coating. This research was supported by Civil Engineering Department of VTRGB, and I would like to thank my supervisor, Dr. Mohammad. And that's all my presentation, and thanks.